Hello everyone, welcome back. Today we're going to be talking about what a polynomial is, and we're also going to answer these questions about polynomials and also state the degree and leading coefficient for examples that are polynomials. So let's dive in. So a polynomial must follow this form at the top that's given right here. Now keep in mind that the coefficients are allowed to be anything, including 0. That's completely fine. However, the powers must be not only real numbers, but positive numbers or 0. So the powers must be whole numbers, right? And so here's some examples. Here we could have a degree 0 polynomial that's called a constant. And that would be something like f of x is equal to 5 or -4 or -2 or 5.5 or anything like that is fine. Then we have our linear, which is the y equals mx plus b form, or here we've written it as a1x plus a naught. So for example, f of x equals 3x minus 2. And then we have our quadratic, right? So where we have a term with x squared, our cubic where we have a term with x cubed, our quartic where we have x to the power 4, and then quintic where we have a term with x to the power of 5. Okay, so the degree refers to what is the highest power. And keep in mind the degree must be a whole number. The degree cannot be a decimal or a fraction or anything like that. And furthermore, none of the powers on any of our variables in a polynomial can be fractions or decimals. So if we have an exponent that is a fraction or decimal, or could be written as one but cannot be written as a whole number, then that's a problem. That means that we do not have a polynomial. We just have some other type of relation or function or something. Now, keep in mind, too, that quintic is not the highest form, right? We can have degree 6, degree 7, degree 8, etc. Polynomials as well, but this is as far as I've written it. Okay, so now that we have some idea what a polynomial is, I'm going to go through the solutions to determining whether each of these functions is a polynomial or not, and if it is, we'll state the degree and the leading coefficient. So this first one, yes, this is a polynomial because it doesn't break any of the rules. We can see that the leading coefficient is 4 in this case, right? Because 4 is the coefficient for x to the power 5, and that is the highest power. And also I can see that the degree is 5, right? Because 5 is the highest exponent on any of these, right? Now you'll notice that, sure, we skipped a couple, right? We don't have anything, we don't have any term with x to the power 4, x to the power 3, but that is okay because our coefficients, that just means our coefficients for those two terms were 0, and that's why they're not written here. So that's completely fine. Okay, let's take a look at example B. Here we have -5x cubed plus 7x plus root 2. This also is a polynomial. Here the leading coefficient is equal to -5, and the degree is equal to 3 because the highest power is cubed, right? So therefore degree is 3. Okay, what about C? Well, this is the first one so far that is not a polynomial. So therefore, we do not need to state the degree or leading coefficient because this is not a polynomial. The reason this is not a polynomial is because we have a square root around the x. And so this could be rewritten as x to the power of 1/2 plus 5, right? It could be rewritten this way. And this is a fractional exponent, which we cannot have. Now, something I want to differentiate is how come this is not allowed right here, this x to the 1/2, but this root 2, which is the same as 2 to the power half, is allowed. Well, here's the difference. The root 2 is a constant, right? And keep in mind that in polynomials, constants and coefficients are allowed to be irrational. They're allowed to be fractions. They're allowed to be decimals. They're allowed to be all of those things. However, whenever we have a power of the exponent like x, right, of our input here, then that's when it's not allowed. And so root 2 is fine because that is just a constant. Whereas x to the power 1/2, well, this is, x is a variable where we are taking it to the power of 1/2, the power of a fraction that cannot be written as a whole number as well, and so therefore it's not a polynomial. So that's the distinction there, because I do often get asked about that. Okay, let's do 3 more. So this next one is 3x to the power 3.5 plus 5x squared minus 8. So this is not a polynomial, and the reason why this is not a polynomial is because here we have 3.5 as the exponent, and again, we can only have whole numbers as the exponents for our variable. And in this case, this isn't one. 3.5 is not a whole number, nor could we simplify it to make it into a whole number. All right, this next one also is not a polynomial. Now, why not? In this case, it's because of this 1 over x, because keep in mind that 1 over x is the same thing as saying x to the negative 1. And negative exponents are not allowed on our variable, so that is a no as well. And then last but not least, we have this one here, and this one is a polynomial. And here we have our leading coefficient is -1, right? Because we have negative x to the power 4, so therefore -1 is that leading coefficient. And the degree would be 4, because that is our highest power on any of these. Now, the only thing that might trip some people up a little bit is that right here, this coefficient is 7.5. However, that is allowed. A coefficient or a constant is allowed to be fraction, decimal, irrational, any real number at all. It's only the powers, right? It's only the exponents that have that restriction of, the exponent couldn't be 7.5 on any of these x values. All right, well, that is all for this one. As always, feel free to leave any questions you have in the comments, and we hope to see you for the next one.